Basically, I just want to make these videos for those set of persons that are having difficulty in a particular aspect of chemistry, which is stoichiometry. Some persons don't really know how to go about it. First of all, stoichiometry is what you apply in your daily activities, but you don't know that you're applying stoichiometry because you look at chemistry as being vague, but chemistry is very, very real. So now, when you say stoichiometry, you have to do with determination of amount of substance, like what amount of substance reacts with also amount of substance. Now, quickly, I just want to give out some basic formulas that will help you in solving some stoichiometrical questions that you come across. Either you are praying for UTME, you are praying for WAEC examination, or other examinations that requires you to know these fundamentals in chemistry. So quickly, I will go straight to the issue at hand. Now, stoichiometry, like I said, I won't waste my time dealing with a lot of definitions here and there. Straight to the formula. So it's just a short video, then begin to look at one or two questions that will help you out as you go through. Now this stoichiometry has to do with measurement of amount of substance. And amount of substance is giving us number of moles. Now, the first formula that you need to know when you're looking at stoichiometry is how to calculate for number of moles. First off, now, number of moles is equals to what? Mass, which we call the reacting mass, over what? Over the molar mass of the compound or the substance you're asking to calculate for the number of moles. Now, this formula is very, very vital. If you don't know this formula, then you may have difficulty or face difficulty in understanding other formulas. So I can easily take this as what? N is equals to mass over molar mass. Now, this formula and this other one is the same thing. So I just use their symbols to represent them. Now remember that the mass is expressed in grams, while the molar mass is expressed in what? In grams per mole. Now, this is equation number one that you must consider. Very easy when you are looking at stoichiometrical questions, so to say. Now, another equation that you must know again from here is that remember that at STP, 1 mole of a substance contains 22.4 dm cube, occupies 22.4 dm cube. Of course, dm cube here is a unit for volume, but which can also be expressed in centimeter cube. That means converting this dm cube to centimeter cube and multiply by 1000. That means 22.4 dm cube can also be expressed as 22,400 cm cube or milliliters. Of course, 1 dm cube is equal to 1 liter. Of course, you know the conversion. So 1 dm cube is equal to 1 liter. Then, of course, cm cube is something as what? Milliliter. Now, leaving that, if you want to calculate, they quickly give you a question and you're seeing STP in the option. Say, okay, 2.5 moles of ammonia occupies what volume at STP. Then, you can use this formula to say that N is equals to V over 22.4 dm cube. Now, please, when to use this formula is when it has to do with gases and the gases are at STP. So when you read a particular question and you see at STP and you are seeing those stuff, just this formula should be part of the formula or that will come into your mind at first, then before you begin to look at it. Now, remember, let's take this as our equation 2. But remember that this is number of moles, and number of moles is mass over molar mass. So I can substitute mass over molar mass into this formula to get another formula, because it's not all the time they ask to calculate for number of moles or to calculate for volume. So all you need to do, sometimes they used to ask you to calculate for mass, so to say. So quickly, you go through this, you can substitute. So if I substitute this N, so I can say since N is equals to mass over molar mass. Therefore, substituting this into this, it begins. I will begin to have what we say now: mass over molar mass is equals to V over 22.4 dm what cube. Remember, I keep on emphasizing either I say dm cube or I say liters, because 1 dm cube is equals to what? 1 liter. Now, this formula is very important when you are going to solve questions on stoichiometry, because you have some questions that we'll be looking at, we'll be checking out as we go. I will proceed with this class. Now, this is equation number 3. This is equation number 1, equation number 2. Now, remember, we discussed something just now that stoichiometry basically deals with calculation of amount of substances. Now, in your fundamentals in chemistry, you know that if I have solutes, if I add a solute to a solvent indirectly, I'm going to have a solution. Now, solute and solvent forms a solution. For instance, if I take salt for instance now, and I add salt to water, I'm going to have a salt solution. So if the concentration of the salt is very, very high, that means I'm going to have brine. Concentration of sodium chloride and what? Water is a solution. Now, because we are dealing with stoichiometry, please put at the back of your mind that amount of solutes and solvents in 1 dm cube of a solution is known as the concentration. So amount of solute and solvent is known as concentration. Now, concentration can be expressed in different ways, in different forms. Now, there's what we call mass concentration, so-called molar concentration, which is molarity, so-called molality, called normality. Now, how do we get to calculate? Remember, this class is basically giving you straight formulas that can help us in solving questions. Now, we're going to bring out questions as time proceeds now. But I just brought out something now. Solving for solvent forms in solution. Now, the amount of solutes, only solutes, in 1 dm cube of a solution is what is known as mass concentration. So amount of solute in 1 dm cube of a solution is known as mass concentration. So this mass concentration can be expressed as what? Can be calculated by saying that mass of solutes over volume of solvent or of solution. Now, if we have made mention of this, ladies and gentlemen, boys and girls, now this formula is another basic formula that you should put at the back of your mind. Those that are preparing for, maybe you're preparing for XSCE, WAEC examination, UTME examination, and even those in higher institutions that do this stoichiometry, you have to be very, very careful. Now, how do you know? Because sometimes they might give you a value and you don't get to know if the value given to you is mass concentration or other concentrations. That means you need to pay attention to the unit in which it was given. So if you know the unit, so to say, now for instance, unit of mass is what? Is grams. Unit of volume is dm cube. So that means if they give me the unit of mass concentration is grams per dm cube, that means if they give me 60 grams per dm cube in a particular question, that means automatically I've been given mass concentration. But that means, or indirectly, if you are solving for mass solution and you get your answer your theoretical examination, your unit should be in grams per dm cube or grams per liter. So remember, 1 dm cube is equals to what? 1 liter. Now, quickly. Now, remember this value here is the the amount of solutes in 1 dm cube of solution. But what about the amount of solvent? That was regarded as what now? As molar concentration, which is also called molarity. So we are going to take it very quickly now. The amount of solvents in 1 dm cube is what? Molar concentration. So molar concentration is equals to moles, number of moles over volume of solution. Now, this formula is used to calculate the molar concentration. Remember that this molar concentration is what is also regarded as what? As molarity. So sometimes they can ask you to calculate molarity. Now, very quickly, this molar concentration is expressing, of course, moles per dm cube. How do we arrive at that? Number of moles is moles. Volume, of course, is in dm cube. Either you say mole per liters or you say mole per dm cube, or you can simply say molar. So if they give you something like this in a question or you solve for molarity, your unit should be in moles per liters, or I can just simply say M, which is what? Molarity. You get it now? So these few formulas, now we have shared about 5 formulas, if I'm not mistaken, 1, 2, then we have 3, then we have 4, we have 5 formulas that you need to look at. The very basic formulas that makes stoichiometry solving very, very easy for beginning to look at questions. But meanwhile, I can derive a formula from this. Pardon me, I need to take this off very quickly. Now, I can derive a formula from this molar condition that I just brought out here. And what formula is that? I can simply say that what? That C, which is molar concentration, is equals to what? N over what? Over V. Now, what does this C, molar concentration, expressed in mole per liters, number of moles, and volume in dm cube? Now, some persons will say quickly that, of course, I can cross multiply, N is equals to CV. Now, some persons will say CV over 1000, but I don't like using that because there are some questions that the volume straight up is in dm cube, so you don't need to convert. So they are divided by 1000. You have to convert the volume to what? To dm cube. But what if the volume is already in dm cube or in liters? There's no need to divide by 1000. So I like to use the raw formula like this. But remember, you put at the back of your mind that the volume should always be in dm cube or in liters. And of course, we said it just now, to convert dm cube or rather cm cube to dm cube, you divide by 1000. But to convert dm cube to cm cube, you multiply by 1000. Now, this formula, of course, is something like this. So I'll call it equation 5 because this one is the fifth formula that we shared now. But remember something from the beginning of the this short video, that number of moles is mass over molar mass. So in place of number of moles, I can simply say mass over molar mass is equals to CV. Now, if I do my cross multiplication very well, I want to make mass out of formula, I can cross multiply. So I can say that mass is equals to, so if this goes to this, it becomes MCV, obviously. Now, this formula is very, very important that you know. It's very, very important when you are given the mass or you are given the volume on, see, it contains mass, molar mass, concentration, and what? And volume. So these formulas are very, very vital. Now, from this particular formula, I can simply, this video is just to bring out some key formulas. So this is what we're going to be doing in my videos. All you have to do is to subscribe if you're watching on YouTube, and of course, to hit the follow button if you're watching on TikTok. So again, to get videos like this that can help you within short time, 10-12 minutes, you are done. Now, look at it. Now, without wasting much time, I can simply say from this formula here, without telling anybody, that for instance, I have a container, and this container I put salt inside. I put salt inside. Now I add water. Right? Now, when you add water, it forms a solution, obviously solvent solute, right? Very good. Now I add more water. Of course, the volume will increase to somewhere here. Now I taste the first volume, the first solution before I added water, and I taste the second one. Which one is more salty? Of course, your guess is as good as mine. This will be more salty. That means as volume increase, concentration decrease. That's what this formula is saying. As volume decrease, concentration increase, or as concentration increase, volume decrease. So it's an inverse proportionality. Now, quickly, if we have stated that fact very fast without wasting time, now coming to this place, I can say that C is inversely proportional to V. Making sense, huh? And you're a good mathematician, you should know this from KG, your kindergarten. Obviously, that if I want to remove the sign of proportionality, of course, I'm going to introduce a constant. That means C is equals to K over what? V. Making sense. Cross multiply. CV is equals to what? K. What's my K? Constant. That means, of course, I can say C1, V1 is equals to C2, V2. Now, this formula is another deadly formula that you should put at the back of your mind. Not at the back, at the front. Now, look at it now. This equation is now equation number 7. This equation is called the dilution equation. Initial concentration, initial volume, final concentration, final volume. Now, this dilution equation is used in when you see questions that pertains to dilution, adding acid to water, trying to dilute the acid and all that. This formula is very, very important. It's on this formula, obviously, that we get to have a formula like CaVa over what? CB VB is equals to what? NA over NB. Now, this is another deadly formula that you must put at the back of your mind. Equation 8 or formula number 8. Now, look at all the formulas that were shared thus far. It's very important that you look at this formula. Now, these are basics of stoichiometry questions. These formulas can handle basic stoichiometrical questions that we'll be looking at from time to time. So look at what we're going to do. Let's write all the formulas out that we have derived today so that you put it at the back of your mind. And of course, you can get to watch the videos from time to time, of course, download them and all that. Now, of course, do well to share and of course like and follow and of course comment. Now, if we have said this, obviously, now let's bring up all the formulas that we looked at just now very quickly. A quick summary. I like to summarize. Now, we're beginning to look at questions. So the next video, we want to bring out questions that has to get that pertains to stoichiometry. So this stoichiometry part 1, of course, there's a part 2 that has to do with mass relationship, where we have to have equations, so to say. Now, quickly, the first formula is N is equals to what? Mass over molar mass. That's equation 1. The second formula is N is equals to V over 22.4 dm cube or liters. This is equation 2. Then of course from here we derive the formula that mass over molar mass is equals to V over 22.4 dm cube. Of course, this is equation what? Equation 3. Then of course we went ahead to say that what? Mass concentration is equals to mass of solutes over volume of solution. Of course, we got out this formula, is very important. Now of course molarity, which is also called molar mass, molar concentration rather, sorry for that, molar concentration is equals to number of moles over what? Volume of solution. Of course, we derive the formula from here, which is this one is also called a molarity, and of course we said that N is equals to CV, of course, all this formula. Then we went ahead to say again that mass is equals to what? MCV. Of course, we did this formula. Therefore, from there again, went ahead to say that C1V1 is equals to C2V2, which is the dilution equation. Then CAVA over CBVB is equals to what? NA over what? ND. Concentration of acid, volume of acid, concentration of base, volume of base, number of moles of acid, number of moles of base. Now, these are basic equations that you must put at the back of your mind as you look at stoichiometrical questions. So, ladies and gentlemen, boys and girls, now don't mind my mask just to prevent chemistry from entering my nose, of course. Now, ladies and gentlemen, on a lighter note, so that is where this is the first video. Now, we are going to look at other videos concerning chemistry questions. So, we got to get the questions that pertains to this. But these are the formulas basic formulas I would like to say that will help you trash most stoichiometrical questions. So there are many videos that you have to look at step by step. Of course, my name is Mojaro. So see you in the next video as we begin to look at questions. And of course, more formulas coming up and more shortcuts and more steps, more basic things that you have to know when it comes to chemistry. Thank you.